Good evening and welcome to the Q&A session 6 from the chapter of nuclei. The topic is the rate of decay of a radioactive substance. And based on this topic, I have one question for this session which is written here on this board. And this session is in continuation of the session number 4 in which we have studied about the law of radioactivity. So here the question is, a radioactive material has a decay constant of lambda per second. Another radioactive material has a decay constant of 10 lambda per second. Initially, both have the same number of radioactive nuclei equal to Ni. That is, at T is equal to 0, the number of radioactive nuclei in both these two materials is equal to Ni. And if the radioactive decay starts at the same time, then the rate of decay of both the materials will be the same at time. So यहाँ पे चार options दिए गए हैं and we have to find the time at which the rate of decay of both the materials are the same. So in the session number 4 we have learned that the rate of decay of a radioactive substance is equal to minus lambda n, and this is equal to minus lambda n naught multiplied by e to the power minus lambda t, where n naught is the number of radioactive nuclei at T is equal to 0. So in this question, at T is equal to 0, the number of radioactive nuclei in both these two materials is equal to Ni. So here, in this equation, this N naught will be replaced by Ni. So for the first material, the rate of decay will be equal to minus lambda, because the decay constant is lambda per second in the first case, multiplied by Ni into e to the power minus lambda t. And for the second material, this rate of decay will be equal to, now here the decay constant is 10 lambda, so here lambda will be replaced by 10 lambda, so minus 10 lambda multiplied by Ni, because in the second material also the number of radioactive nuclei at T is equal to 0 is equal to Ni multiplied by e to the power minus, now here lambda will be replaced by 10 lambda t. So I am getting these two equations, that is dn is equal to minus lambda n I into e to the power minus lambda t for the first material, and for the second material the rate of decay is equal to minus 10 lambda Ni into e to the power minus 10 lambda t. Now when the rate of decay of both the materials are the same, then minus lambda Ni into e to the power minus lambda t, this will be equal to minus 10 lambda Ni into e to the power minus 10 lambda t. So from this equation, I will get another equation, that is here minus lambda Ni will get cancelled on both the sides of the equation. So I will be left with e to the power minus lambda t. This is equal to 10 e to the power minus 10 lambda t. Now dividing this equation on both sides by e to the power minus 10 lambda t, I will get e to the power minus lambda t divided by e to the power minus 10 lambda t. This is equal to 10, or it implies that e to the power 9 lambda t, this is equal to 10. Now taking log on both sides of this equation, I will get 9 lambda t log e to the base, here I am taking the log to the base 10. So 9 lambda t log e to the base 10, this will be equal to log 10 to the base 10. So here 9 lambda t, now log e to the base 10 is equal to 0.43. Its approximate value is 0.43. So this is something which you all have to remember. That is, log e to the base 10 is approximately equal to 0.43. And now log 10 to the base 10, this is equal to 1. So from here, 9 into 0.43 9 into 0.43, this is equal to 3.87. So 3.87 lambda t is equal to 1, or t is equal to 1 divided by 3.87 lambda. So here t will be equal to 1 divided by 3.87 will be equal to 1 divided by 3.87. This is equal to 0.258 divided by lambda. And this will be in seconds. So the correct option here is A. So the most important thing in this question was the utilization of the equation of the rate of decay. Means I have utilized the equation for the rate of decay of a radioactive substance, which is equal to dN upon dt is equal to minus lambda n, and this is equal to minus lambda n naught into e to the power minus lambda t. So with the help of this equation, we were able to find the time at which the rate of decay of both these two materials are the same. So the correct option is A, that is 0.258 upon lambda seconds. So thank you very much for joining this session. Now in the next session, I will be again coming up with a different type of a question from the topic of law of radioactivity. So till then, have a nice day. Bye.